As we think more about calling methods, and in particular recursive methods that are going to have to call themselves possibly many times, it's important to also think about when we return from a method, what happens. And so what I'd like you to take a moment to think about is if the JVM, the Java Virtual Machine that runs your code, reaches a return statement like return 3 when running a program, not when compiling the program, but when running it, what are the things that the JVM actually has to do there? It doesn't just step to the next line of the program. There are some big changes that happen when you reach a return statement. So pause the video for a moment and think about what those changes are and what the JVM has to do when it reaches a return statement like return 3. Pause and think about it. So a few things that occur to me when a return statement is reached is it needs to actually return to where the method was called. Right? It will return back to whatever line of code that the method was called on. It will also insert the value 3 wherever the method call was. And it won't actually do this, but we can sort of pretend that it kind of scratches out whatever method call was there and puts 3 in its place so that the value 3 would be used if someone had said x equals my function whatever, and my function returns 3, then x will get 3 assigned to it. In addition to this, it also needs to make any methods within the current, any variables within the current method no longer be accessible. So make variables of the current method not be accessible. And the same goes for the parameters too. So anything that was specific to the method that is returning, it should no longer be accessible. We're outside of that method after we return. And then it should make the variables and the parameters of the place that it's returning to, of the method it's returning to, accessible again. So it sort of removes the variables and parameters for the method that's returning and sort of restores the variables and parameters of the method that called my method that's returning. So there's a lot of inner workings of how it does this, but today we're going to focus on this idea of an activation record. So an activation record is a record that's created by Java for each method call that will store things like the variables within that method, where it's going to return to, some other things like that. And you'll play with those as you work on the activity. But before that, I want to look a little bit at how this would actually function in code. So an activation record is a data structure built by Java for each method when it's called. And when that method is done, then its activation record can be removed and deleted. So it will hold the spaces for what are the local variables, what are the parameters, etc. It also means that if my method calls to another method, then my method's activation record is kind of put on hold. It's actually stacked, a new one is stacked up on top of it. And if that method calls another method, a new activation record will be made for that third method and stacked up on top of it. And they'll keep stacking as methods return. They're kind of lifted, their activation records are deleted and sort of lifted up off of the stack. And whoever was below them in the stack will have their items restored. So let's see this a little bit in practice with some code. All right, here I've got some code that's in a class that's just called main. I have a main method. It sets up some variables. It then calls to this combine method, which has its own parameters and has some local variables of its own. And that combine one will return a result, and that result will be used as, well, first stored in this variable called whole, and then used to print out. So what I want to do is I want to actually run through this and see what happens in the runtime as we're executing this code. So let's run it in debug mode. All right, so as I run in debug mode, we see that it pauses at the breakpoint here. The only variable is the args parameter. And as I step forward, the section variable gets created and given a value, and we can see it down here. The course variable gets created and given a value, and we see that listed down here too. I could even expand it and see each of the characters in it and so on. And then I step into the combine method that's called right here. And as I do that, you're going to see everything change here. Because section and course as variable names are not accessible anymore. I'm not in the main method anymore. So none of its variables are accessible. Its activation record got set aside, and then this new one for combine got stacked on top of it. So combine has all these parameters, and we can see the values for those parameters. And then as I step through, it's going to build the return value here by combining the word, the connector, and the number. It's built the return value, CS416, section 2. And then once I step from this return statement here, again, we're going to see all this change because the activation record for combine is no longer needed. It will be removed and will restore the activation record of the main method. So we come back to the line where combine was called. Its result is going to get stored in this string variable called whole, and there it does. And all of the variables for combine no longer exist. They're no longer accessible, and they don't have any values. And so we can see as we step into one method, then all of the variables and the space from the original method gets hidden for a minute. And when we come back to that original method, they all get restored. And this is what your recursive methods are going to have to be doing over and over and over again as they call themselves. There will be a new activation record created for every single recursive call. And you'll look a little more at these ideas as you work on the Recursion 2 activity Model A.